Hello and welcome to our channel. In this video, we are going to tackle an optimization problem using calculus. In calculus, optimization refers to the process of finding the maximum or minimum value of a function subject to certain constraints. This question, suppose that we have 100 feet of fencing and want to enclose a rectangular garden. What dimensions should the garden have to maximize the area? To start, we can set up the problem by calling the length of the rectangle small letter L and the width small letter W. The perimeter of the garden is given by perimeter equals to 2 length plus W. In this case, it is 100 feet. Now, with this equation, we can find length plus W by dividing both sides 2, and that gives us 50 feet. Our goal is to maximize the area of the rectangle, which is given by the area of any rectangle is length multiplied by width. To do this, we need to eliminate one of the variables in the area equation using the constraint equation. This is called the constraint equation. So we make L the subject of the formula, and L is the same as 50 minus W. So with these, we can substitute here L, and therefore the area will be 50 minus W multiplied by W. This gives us 50W minus W squared. Now we have a function area. We can take its derivative and set it equal to 0. That means area 50W minus W squared. The derivative of A will be A prime is the same as 50. Okay, first of all, how do you find the derivative of 50W? Now what we do is we reduce the power of W by 1. That gives us 1 minus 1, and then minus. We take for W squared, we take 2 multiplied W, and then reduce the power of W by 1. This will automatically gives us 50W power 0 minus 2W. Okay, W power 0 is the same as 1, and finally the derivative of the area will be 50 minus 2W. So like we said before, we can take its derivative, the derivative of the area, and set it equal to 0. That means 50 minus 2W is the same as 0, and therefore 2W is 50. That means W is 25. That being said, we can go back to the constraint equation, this equation. We can go back to this one and find L now. L is, like we said before, is 50 minus W, which is 50 minus 25. Therefore, L is 25. So the optimal dimensions for the rectangle that maximizes the area is 25 feet by 25 feet.